My name is Dat Ngo. I'm a ML solutions architect here with Arize. I do a lot of building with our customers, kind of at a really deep level. And it's been really great seeing really kind of how everybody's been kind of entering the LLM space, the generative space. So it's been really cool building with all the different teams that we work with and getting to see kind of their progression. But really nice to meet you all. Really excited for today's presentation.
Awesome. And yeah, hey everyone. My name's Aparna. Similar to Dat, just been seeing a lot of companies actually put LLM applications into production and start thinking about evaluation and what does that look like in development, but then also in production. So I work on product here, so deeply interested in kind of how folks are using this type of technology. And what we thought we'd do today is share a little bit about different classes of evals. Lots of you are probably familiar in the ML sense of there's regression models, classification models, and there's different common metrics on how to evaluate those type of models. We're starting to see kind of a spread here too across the different LLM evals. So today, Dat and I will go through a couple of the different classes of LLM evals that we're starting to see people actually put into production, our take on it, what we recommend, what we don't recommend. And then you'll actually see today probably a lot more of like the hands-on demo aspect of it. So we'll actually show you our open source product that people use for looking at their LLM evaluations.
Awesome.
Cool.
All right, let's get started.
And like always, drop questions in the chat. We'll be looking at them and everything. So feel free to do that. Okay, awesome. I think this might be a little bit of a review for folks who were there last week. But there's a lot of different type of evaluation metrics that we're starting to see out in the world. First off is a numeric set. Things like, oh, it's a range or a number that you're typically predicting. So can you score this summary? How well is this summary between some range of 1 to 5? How toxic is this response? All of these, as long as you ask it for a score, it's kind of a numeric eval. I'd say this is less popular than some of the more categorical ones that we're actually seeing in production. So the two probably most popular set here you'll probably see is like the binary versus the multi-class. I don't know about you, Dat. This might be a good question. I've been seeing binary more out there being used. Would you kind of agree with that? You seeing, I don't know, mix? What are you seeing?
Yeah, that's a good question. I definitely agree with you. I think it's very rare to see a numeric kind of evaluation or LLM evaluation. I think what I really do see a lot is definitely categorical or maybe the other, multi-class categorical. And I think we'll later kind of go into reasons for that. But for the most part, I would say probably 95% of folks really using you can think categorical binary, categorical multi-class. So yeah, that's what I'm saying.
Yeah, yep. And really the difference between binary and multi-class is with binary, there's kind of two options. So is the summary correct or not? With categorical, I mean, the common one we're seeing is things, especially in RAG type of use cases, if you have a question and answer, is it fully correct, partially correct, or incorrect in total? And so in that case, you'll kind of see a little bit more of the multi-class use case. This other one's kind of interesting, which is multi-output. Really what we mean here is that you're not just limited to one LLM output, eval output. So in this case, we see teams using two evals. So both of them might be binary, both of them could be multi-class. But in this case, there might be something where it's like, is the summary correct, which is really just focused on how factually correct the summary is. But then there's also, is the summary concise? And with summary concise, what you're really looking for is it wordy? Did it get, did it say it in a really quick way? So in this case, you might have a summary that's both correct but verbose, or incorrect and concise. And so they're both flavors of what you probably don't want.
Yep. And for context too, I think if you missed the previous series on like evaluations, what are they? I'm going to TLDR this, but turns out large language models are actually really good at you can think grading themselves, or really saying, hey, is the thing that I answered, can I grade myself? And we'll go into detail kind of what that grading is kind of here, kind of more into depth. And also realize that we have kind of an open source kind of library. So if you are thinking or planning to use large language model evaluations, we have a really great framework kind of in Phoenix. I just wanted to cover that. Awesome.
And we'll go into it as we're going through this. Okay, so first off, just wanted to give you a quick example of what a numeric eval could look like. So again, all of these are an LLM evaluating itself. So in this case, it's an example where users give it a bunch of tweets from, let's say, customer service. You have to just determine how good the customer service was based on the tweet. You'll see here, this is where the format matters, your response. You pass in the tweet, then it goes, your response must be a single number between the range of 0 to 1, with 0 being very poor and 1 being impeccable customer service. And so the LLM will actually grade the response itself. And maybe you can go to the next slide, Dat, and then we can jump into a quick demo of it. I think one of the reasons we're seeing numeric evals probably not as popular out in the real world is I think this is just a note to be mindful of it. You might have something where across all of your scores, they might be an average. If you're looking at something like the average across all of your numeric evals, if you take the average across all the evals, you might, in this case, if each of the individual points were 0 0.5, 0 0.5, 0 0.5, it looks like the evals, the evals actually stuck at 0 0.5. So your answer is kind of in this case, the eval would have said that everything is neutral in terms of a tweet versus something like the one on the right, where you actually have a range. You have things like, some that are graded 1, great customer service, and some that are graded 0.2, which is poor customer service. This might actually be able to distinguish the nuance between the tweets. But so it's kind of like a working relevancy or working kind of, customer service prompt. But when you take the average, they both look the same. They both land at 0.5. And so if you're going to use it, that's fine, but at least look at things like the standard deviation or the range so that you can at least understand, okay, there's a large spread as opposed to, there's a big difference between these two evals. And it's just not obvious if you just look at one aggregate metric. So we actually recommend, if you're using score-based evals, to actually make them binary 1 or 0, because there's a lot more we'll get into around looking at things like the precision and the recall in the next couple of these that are actually slightly better to help you tease out what's not working.
Yep. And I'm actually going to show an example of this. Whenever I first started kind of building in kind of the space, like many months ago, I actually built this kind of cool little kind of demo set because I was working kind of with evaluations. And this really illustrates kind of what Aparna was saying. And so here, what this use case is we actually have like a set of, like, you can think tweets or airline tweets. So for example, this might be a tweet. It's like, hey, Southwest Air bags fly for free. And the kind of experiment I was doing was like, hey, can I extract out all the kind of airlines that I'm looking for? And so I wanted to see, hey, how well does this, airline do? I also had like a human, label on it to see, hey, these are the correct answers. Let's see how well this kind of large language model does. And so not only did I extract, the airline tweet or the airline out of the tweet, I also did kind of an evaluation too. It's like, hey, your goal is to kind of grade how well you did on a scale from, you can think, 1 to 10, where 10 is being very certain, and 0 indicates there was an error. And this really highlights kind of what Aparna was saying. There's a lot of ambiguity in the scoring if you don't mention, like, hey, what's a 5 or what's an 8 or what's a 3. You're kind of assuming that the large language model can kind of make an assumption of like, hey, this is what this means. And so we kind of ran this kind of these functions. So not only kind of at the end of everything, what we got was really here were the airlines, kind of you can think the ground truth from kind of a human labeled data set. And here was kind of the extraction. For the most part, I think the large language model was able to kind of pull out most of you can think the airlines, with some nuances here. Maybe we pulled out maybe United instead of United Airlines, but it still gave it kind of a 10. So a little bit of that ambiguity kind of showing up. and maybe why it's less commonly used. And things like this where, we actually found like I wanted to find where the grades weren't zero or where they were zero or maybe not 10 because most of them were coming back 10. We found out that in some cases, we kind of messed up, which was, kind of expected. But maybe we got an 8 here, and eight's a little bit ambiguous, but it was really where the ground truth was U.S. Airways, but the extraction that we pulled out was U.S. Airways and Finnair. And when we look back into you can think the original tweet, turns out the ground truth, label was actually kind of wrong. But still a lot of ambiguity here just to highlight kind of what Aparna was saying, maybe why this is kind of less used. But wanted to quickly show an example of kind of numeric kind of evals. Awesome.
When we get into the next one, what we'll actually do is show you Phoenix and how to run it, because I think you'll start to, it's an open source library. You guys can try out how to run LLM evals yourself. So next one, we'll just quickly cover binary. This is a simple, this is actually, if you could go to the Phoenix eval docs, we could actually talk about these. So for those of you who are not familiar, Phoenix is an OSS library. It's used for LLM observability. You can do LLM evals with it. What it comes straight out of the gate with is some pre-tested evals, as well as you can make your own custom eval. So the most common pre-tested evals, maybe the page above it, the running, perfect. So typically here, these are kind of the most common evals that we're actually seeing folks run in production. If you're using a RAG type of application, they'll use things like retrieval, Q&A. If it's a summarization application, you have product summaries and you want to give a description of them. Typically, you're evaluating how well the summary is. The example I was just talking about right now was the toxicity eval. So if you click on that one, this one's basically evaluating how good was, how toxic or not toxic was the response. So the way that this eval works, again, if you could zoom in, Dat, it's basically a LLM call. And what you do is, this is the prompt. We've tested this prompt on public data sets. You can actually see all of the benchmark kind of scores down below on this page. But here what we're doing is just evaluating how toxic the response from the LLM was. So we have, for example, some customers who have applications that might be exposed to children or might be exposed to a sensitive population. And so you want to make sure that before you give the response, it's not truly toxic. And in this case, what we've done is defined what toxic is. So it's defined as a comment that makes hateful or not. And then it's binary because, again, down below, it says your response must be a single word, either toxic or non-toxic, and not contain, anything else. And then again, we define what toxic is and we define what non-toxic is. And so in this case over here, if you scroll down below, you'll see kind of the benchmark results running this on GPT-4 versus GPT-3. A lot of these actually, by the way, we've been running them on GPT-4 Turbo. GPT-4 Turbo has been really, the latest GPT-4 Turbo responses. If you scroll, perfect, if you scroll up, you'll see that by and large, so it looks like in this one, GPT-4 is still better, but if you go to some of the other evals, GPT-4 Turbo is actually pretty dang good, oftentimes beats performance of GPT-4. It's cheaper and it runs like at least 2x faster. And so, just a side note that, picking the eval LLM could also make a difference in those evaluation scores.
Yep. And one really cool thing too that we can do with these binary, you can think kind of labels or kind of coming to the evals is you can start to build out metrics that you might be more familiar with. So that might be precision, recall, F1, etc. And so we've kind of benchmarked these out here. So please have a look at these. I think it's, we put a lot of work and a lot of these you can think inside of our Phoenix eval, we have pre-tested data sets. So you can think data sets that are already graded for you. And of course, you can always take the framework here. You can adjust the prompt to match your specific business use case. So maybe it's a specific type of toxicity or you want to adjust the prompt. Or maybe, maybe you don't want to use our kind of golden data set. That's okay, but at least you have something to kind of benchmark and get you a feel for that. You can always use your own golden data sets as well.
Yeah. Um, one maybe we could do let's do one more slide and then we'll go into the demo with the traces actually.
Perfect.
So again, what Dat was hinting at, so you've generated these binary evals. How do you aggregate them? This is really important because when you want to monitor these type of things in production, you typically will, or you're trying to evaluate one prompt versus another. You want to compare, okay, how well did this prompt do overall compared to another prompt? And so I think here also, one key note here is just, if you look at a lot of the benchmarks online, you'll typically see people talk about accuracy. I think it's obviously the most easiest to understand. I think the key thing just to highlight here is, again, this is if you have an imbalanced data set, you're not going to want to use just accuracy. You're going to want to use things like precision and recall. And the big one, maybe just to give you guys an example here, is I just had a quick example. You guys are all familiar with this typical confusion matrix. But in this case, the positive tweets, I guess, are kind of the imbalance class. So there's typically, when you think about what people are posting online, typically it's probably negative. And so they're going to some platform to complain. And so typically it's kind of an imbalance class. And so if you're looking at something like accuracy, oops, there's actually 10 there, but there's actually kind of, 9 out of 10, they actually got it right. But if you look at something like precision, which is how many of the positives did it actually guess truly correctly? In this case, only half of them it got right. And so this is just one where, don't just rely on accuracy, use precision and recall. I think that's the biggest takeaway that you can do when you're doing aggregates of binary evals.
Yep, I would agree with that. And what we see, I guess what I see with my customers is kind of the same thing. I think large language models are actually really great. And the thing that you're really trying to find is actually more rare. And so definitely 100% agree with that.
Yeah.
Um, I think do you want to go into
Yeah.
the traces? Okay.
We'll show the traces too.
Awesome. So I'm going to walk you through, just for context, kind of what we're doing here. So we do have kind of, you can think of kind of like a RAG kind of use case here. And what we've done here is we've ran kind of this RAG, and it's really a RAG based off of, we have kind of Arize documentation. We let our customers kind of ask, the chatbot, hey, how do I use Arize, things like that. We wanted to see if our RAG, bot did really well in answering our customers' questions. And so the first thing we're going to do is we're going to kind of, we did our kind of imports, and then we're just going to launch Phoenix. So as I'm running, you can think the evaluations on kind of this data set, it'll kind of flow into the kind of the UI, which we'll go to kind of here in a second. And so what we kind of have off the bat in terms of data is, let's say, kind of maybe our inputs. So what are our customers asking? Hey, can I copy a dashboard? How do I send embeddings in, etc. We have a reference column, which you can think of as like, hey, I'm injecting some relevant piece of context, or you can think I'm doing a RAG to find, hey, these are the documents that kind of apply. Of course, you might have like a document score or some sort of similarity score. And then here we also have kind of the context, or kind of the trace, which will come in handy whenever we're looking at our traces view. And so here we're just setting up OpenAI to kind of do our evals on. And then here we're going to evaluate the first evaluation, which is our document relevance. So, hey, is the document I brought back for this question, you can think relevant in answering the question, or maybe not. And so here we're using really awesome like helper functions in Phoenix. And so I'm going to give a little plug to Phoenix here. If you haven't used it, you definitely should be. If you're even, if you're thinking or doing evals, one really cool thing about Phoenix is you have these really great helper functions that kind of do exactly what you need. It gets rid of a lot of the kind of the code you need to build to just run these evals. And these evals kind of run at scale. So they happen extremely quickly. You can think, you can really beat a lot of, you can think evaluation, maybe libraries in terms of scale. So running these on a very large data set, it's really what Phoenix was built for. And so here we kind of run this kind of evaluation set on whether or not, hey, was the chunk relevant or irrelevant? In this case, we had kind of two documents. And so realize that's kind of the first eval that we ran. But we didn't just run one eval here. We actually ran kind of multiple. And so here, what we're going to do is we're just going to attach kind of those evals from the RAG. And then we're going to continue on and then compute other kind of metrics as well. And so here, based off of, um,
Maybe just to
yeah,
recap short, I know it's a lot all at once. So I think that the first big one is just, okay, so it's a RAG application. We're retrieving some docs. We're doing some retrieval, and then we're using that to answer kind of a Q&A question. So within this, we're setting this up to show you guys kind of like a multi-output example. We're going to have multiple evals that we're going to talk through. The first one the DAT kind of was just covering, if you scroll back up, is kind of the relevant or irrelevant. This one's actually a really good one to just cover for a second. So this is actually using a binary eval. And we're going to jump into Phoenix to show you what that looks like. But in this case, if you just zoom in for a second, that basically what this one's doing, this is actually, if you can just open up the Phoenix pre-tested evals, we can show them the prompt to understand it. Basically what it does, oh, the docs
oh,
to show
okay.
the eval itself. Perfect. Yep. So here what it's basically doing is it's taking the query that the user asked, the reference that was retrieved from the vector store or wherever, and then you're actually using that to ask, hey, well, is this reference actually relevant to the query that the user was asking? And so again, there's only two outputs, relevant or irrelevant. So binary eval, it's one of the core ones we'll talk about as we kind of look at all the traces, but this is kind of one of the core ones we're going to cover. Do you want to maybe just show that in Phoenix first before we jump into all of the rest of them?
Yeah, that's a good point. So here, when we ran, you can think here's all those kind of questions that we kind of reviewed. We can open up one really quickly. So in the first step of our RAG, right, we did a retrieval step. And the really cool part is like in Phoenix, I can trace through the different, you can think, parts of this chain that I'm kind of running. And so I can see not only the documents that kind of were returned, I can see the score. And maybe if we go to evaluations, we can take a look at, hey, what was the evaluation here? So in this case, we had what looks like relevant and relevant, and we can calculate things like maybe NDCG at 2 or precision at 2. Let me actually pull up one with maybe an explanation where something maybe went wrong really quickly.
Awesome. So
Okay.
in the one, perfect, yeah. If you go back to, so what that's actually showing here, so this is Phoenix. Within Phoenix, you can see um, all of the, so simple callback, and we log all of the calls that you're actually making. I'm seeing, you can do this if you're using something like a Llama Index or a LangChain application. If you're directly making calls to OpenAI or et cetera, you can also use Phoenix as well. All of the kind of listed kind of supported LLMs I'll drop in the chat afterward. But what we do is behind the scenes, every time you're making a call, we collect the entire, you can think about it like the stack trace. So, because under the hood, it's making a lot of calls. And so when you click on one of the chain up above, so this is actually a question that someone asked our chatbot, can I send truth labels to Arize separately? And these are all the steps that actually happened under the scene. So first it went to the retriever under the scenes, and of course did an embedding to actually embed the question that the user asked. Then it pulled the relevant context, re-ranked the documents, and then, it bubbled it back up. You can see if you go back to the retrieve span, then you can see here, these were the kind of documents that it ultimately picked. In this case, each of those documents is actually where we've attached our relevance eval to. So if you zoom into one of the documents that you'll see, yeah, you can just zoom in. Yep, it says relevance, is it relevant or not? In this case, it looks like it's pulled the doc that's actually irrelevant. And that makes sense. If you just look at the first link up, if you look at the context of the doc above, it says sending 10 million inferences to Arize in 90 seconds, collab link. This has nothing to do with sending ground truth back. So this is actually one where the eval it's very clear that it's actually irrelevant to the question that the user's actually asking. But if you scroll down, okay, it looks like the second one's also supports sending in historical data up to 2 years. Again, this has nothing to do with ground truth. And so also irrelevant. So each of the context in this case can actually, and this is the key point, is that evals can be attached to either a trace, they can attach to either a span, or they can also be attached to a document within, when you're using it to troubleshoot. I'll keep going back.
Awesome. No, I really appreciate the context. For those who haven't seen maybe Phoenix, that's a really good way to think about it. And so when we go back into the code, I know I kind of skimmed over that, but yeah, that's essentially what you can get out of it and what's happening here. So as we're sending that data into Phoenix, we can get that kind of information in terms of, hey, what's going on with the retrieval? But again, things are a little bit more complex than just that. So we're actually going to go into the rest. So we did compute NDCG using, you can think the LLM scores from the RAG kind of eval. We computed precision. The next thing too that we can do is we're going to calculate using kind of a Q&A kind of grading. And so here, what we can do is we can evaluate the question and answer correctness. So like, hey, outside of RAG, did I answer the question correctly? Because it may turns out like, hey, you may have, produced the wrong, you can think chunks or documents back, but maybe your LLM has some sort of context that it's been trained on. It still answered the question correctly. So that's kind of what we're grading here is like, hey, can we evaluate the Q&A correctness? I can go over kind of what that template looks like as well. You can go inside of Phoenix and look at that. And so we have a score here too. And one other thing to note too, inside of Phoenix, we actually allow for folks to do explanations. So this is super important because a lot of times when you're debugging, especially with LLM evals, it increases, I guess, essentially like what the issue was, or the LLM here is explaining, hey, I chose that the Q&A was incorrect, and here's the reason for it. And it really helps you pinpoint down the issue that it thinks rather than having to read through, oh, here was the question and here was the answer. Let me try to figure out semantically what the issue was. The LLM will just go ahead and explain kind of what this is. We'll go into kind of depth
Do you want
here.
to actually, just given 2 minutes left, do you want to maybe just go into Phoenix and show what an explanation looks like? Because I think that's probably one of the big takeaways from we've learned from seeing evals being used.
Yep. It's a good point. So yeah, so if we go over, you can think to this particular, span or trace. We can look at the two kind of we did a Q&A correctness eval and also a hallucination eval kind of side by side. So this is where we can actually have like a grading rubric. So you don't just have to choose one eval, you can actually combine them. And so here's the label. We kind of got it incorrect. And obviously the score was a 0. And really the explanation here, the reference text does not explicitly mention the ability to send truth labels separately. Kind of very similar to what Aparna just kind of read and figured out. The really cool thing is you don't have to do this cognitive work. You can actually delegate this to the LLM. And so, yeah, Aparna, anything else you want to add in terms of explanation or why it's important?
I think the big one here is just so maybe you can just flash the part in the docs that this is definitely one, if you guys are using LLM evals, it's one that you probably have hit where you're like, okay, why did it score something a certain way? And so we built out this awesome support where if you just ask it to provide an explanation, you can then ask it to explain the score that it came up with. And typically this will also give you an indication of what went wrong. So context wasn't relevant, or it wasn't fully answered correctly, or it missed this part of the answer. And so this is typically, instead of you trying to figure out, okay, these are all my bad scores, and here's what I need to go to do improvement on the LLM application, sometimes just looking at the explanations give you the right direction on what to go do.
Yep, you nailed that one. And so part of the kind of where we're kind of coming up on time here, but the rest of kind of the presentation was really covering, You can think, it doesn't have to be, you can think relevant or irrelevant. You might have things like, hey, given this, reference text, did you answer the question, was it fully correct, partially correct, or incorrect? And so just realize that you don't have to be gated to just binary. You can actually go, kind of multi-class here if there's more nuance to your data. Um, Aparna, anything you want to add to this slide?
I feel like this is, yeah, no, I
Yeah,
think
pretty
this is good.
straightforward.
Maybe the last one, just to make one key hint on, is and you can show this in Phoenix itself, is that um in the Phoenix product, yep. So if you zoom out for a second, to all the traces. So I think the key takeaways as you guys are thinking about evals is, one, you can have multiple evals on a specific call. So if you zoom in this case, there's Q&A, there's also hallucinations. Um, Within a specific trace, you can also use explanations to help you understand what truly went wrong. And then evals can also be put on the spans of the documents itself. These evals can be of different types, multi-class, binary, numeric, but I think the key important thing is that being able to get this type of visibility into your application helps you know where the app's doing well and where the app's not doing well. And what we'll do is we'll follow up after this with slides and also a collab tutorial so you guys can all try this and run it yourself.
Awesome.
Awesome.
Yep. Yep, we're really excited. If you haven't used Phoenix, yeah, we'll share out this notebook, and you can definitely just run exactly what we just ran here.
Awesome. Thanks, everyone. See you.
Awesome. Thank you so much. Cheers.